even with robots, I mean, obviously they're, marvels of engineering in their own right, and I think they've almost gotten to the point where they've become components in industrial machinery. So, what might be some of the more intriguing examples that you've seen of robotic integration into, say, machinery itself, or even into robotic work cells?
It's a great way to think about it. Robots evolving from standalone marvels, like you described, to
Right.
crucial components within a large automation systems. And I think, I'll maybe talk about some examples around it. There's a company that we know that we're working with, and they make I'll say the privacy components in the public bathrooms. And
No.
we don't think about that variety of what that means and to process that, and to be able to build a system around managing that. In fact, that particular customer has 1,000 SKUs, and we've all seen it just sitting in, you go in, and sometimes the space is really tight and short or high, and sometimes the space is really wide, and again, having different configurations. So dealing with all that in automation systems. So it's not just a robot now, it's really putting together different technology to come up with a complete system. So as you say, I like the way you thought about it, as it's not a standalone marvel anymore, it's part of the system. Even, because of some of the things I talked about earlier with, AMR technology and what that looks like in solar fields, now they have opportunity to move equipment with robot arms in a solar field autonomously to put panels in place. And it's an ergonomic nightmare for people. In fact, you can't generally pick up a panel by yourself. It's going to take 2 or 3 people. And even then, the wind blows a little bit. So we're able to use mechanisms as a system now to put together a complete system. And so examples of that, even where none of us would have thought about, again, so many years ago, in places like Quick Trip. I don't know if you know Quick Trip where
Sure.
where you are, but big chain, and they loading the backside of the coolers, and then so it's a complete system going through managing all the different SKUs there, and where they have to be, and also keep in mind that there's a human interfacing on the other side. So managing all that communication, so there's a robot component, but there's so many other things that make the complete system. And even more I'll say more what we'll call traditional areas, like imagine CNC machining center, where robots autonomously loads and unloads workpieces. The robot uses vision. It's not a standalone device anymore. It identifies the correct part, places it precisely in a machine fixture, so it's interfacing with the machine itself, so that communication, and it can be unintended, and it really is one of the things that kind of takes away that old challenging thing of high mix, low volume used for robots, because of these emergings of systems around this technology increasingly being integrated. So I think those, and even cobots, I mentioned those earlier, using, I'd say it's an application. I don't like to say the word cobots because I don't really think that exists. I think it's collaborative applications, not the device itself, because it really is how it's applied. Because I put a razor blade, it's not really collaborative at that point. And even though the traditional areas like robot welding, and but now it's integrated with vision. So and even that in itself, it used to be just welding. Then we added some components of software recognition and et cetera, and that's evolved where you can today that it ensures consistent weld quality even with slight inconsistencies, because it can in real time identify variations and adjust the welding parameters based on input of other sensors and information. So I think and again, some talk about some of those welding integrated systems. They bring other processes in today that we might not have done in the past, like say grinding after the weld. So now you can do a robot grinding and polishing, all part of the same complete system, right? Rather than individual components. So that's a real value of where that's gone. I think as far as technology changes, and even some of the I keep talking about some of the more traditional things. We don't think about how that's evolved so dramatically over the recent evolution of technology. Automated palletizing and layer optimization. Robots have been around for a while, but however they've been, palletizing. But there's some interesting developments in complex product identification, layer optimization, robots not only stack boxes in the pallets, but they also use software to optimize the stacking pattern for
Right.
stability and space utilization, often adapting to mixed product loads. There's so much going on in even areas that we would have said more traditional use of robots, but because it's not those isolated marvels, but a wrong system utilization because of all the other developments in the technology, even 3D printers. They certainly COVID moved that forward, that technology quite quickly because of the needs of some of the things in the market. But now that is even having robotic systems supporting bringing the powders to the system, and it eliminates human exposure, potentially hazardous materials, etc. But again, it's a complete system rather than just very isolated islands of automation.
I was just thinking back to the Automate show each year and how, you know, years ago, maybe I mean, of course, you'd see machine tending. Okay, robots for machine tending. What a novel idea. Then you see robotic welding. And then each year, I'm seeing more and more applications where they're building a system, that and the robot provider is partnering with another company that's developing, a piece of equipment that comes as one unit that you can implement within your operation. And the list just keeps expanding every year.
I agree. I think that focus on creating these intelligent integrated systems that can optimize efficiency, improve quality, and adapt. It also gives us the ability to adapt to changing manufacturing needs. So it's really exciting, as you say. Automate's a good place to see a lot of that, but the synergy between the robotics and the other sensing capabilities, advanced sensing, intelligent software, it's making these integrations really, truly intriguing.
But then now, you're talking about AI, specifically agentic AI. And,
Mm.
as robots become, more intelligent, not just generative AI where like, yeah, I can use it to write code, really more like this robot has the ability to think and
Mm.
act on its own, and they're mobile. So when you put that kind of adaptability to manufacturing itself, how does that affect the way you design a system or a line, or do you even design a system or a line now?
I mean, I would say, the merging of robotics and agentic AI holds certainly significant potential to really revolutionize manufacturing, as you say, adaptability, the fluidity of engineering capacity. While there's still needed more development maybe in this area, agentic AI empowers, robots, as you described, kind of beyond the pre-programmed instructions. They learn from their environment, understanding changing tasks on the fly, dynamically allocate work among themselves, even in collaboration with human workers. So I think this does allow, production lines to adjust rapidly and to fluctuating demands, unexpected disruptions, which is one of the things that, that human element aspect has been beneficial to semi-automated systems, and actually gives the opportunity for customized products. I think one of the real benefits, and again, it's still an evolving piece in the space for sure, but software is one of the great, exciting, rapidly changing things. Analyzing real-time data from sensors and production metrics, it can continuously fine-tune the production parameters, and we tend to do that generally as human beings ourselves, right? But now it gives us the opportunity to identify those bottlenecks, optimize workflows autonomously. This leads to potentially increased throughput, reduced waste, and greater overall operational efficiency, kind of real time, rather than looking at analytics and saying, seems like we're getting too much waste. What's causing that? This is
Right.
kind of evolving where it can do it for us. It's an intriguing opportunity. The autonomous quality control, integrating agentic AI with computer vision, other sensor technology, it may be possible to enable robots to autonomously inspect products during production. This could potentially identify even minor defects in real time and trigger corrective actions, leading to a higher quality product, overall, and again, as I said, reduced waste. I think it's pretty exciting there. I do believe, or there's hopes that analyzing vast amounts of engineering manufacturing data that we talk about can provide engineers with valuable insights, inform their decisions, optimize designs, improve processes. I don't think it eliminates the engineering, it just makes them more help with predictive potential, leads to more efficient and effective use of engineering practices.